वेलकम टू फिजिक्स क्लास। तो आज हम लोग बात करेंगे टोटल इंटरनल रिफ्लेक्शन। अब टोटल इंटरनल रिफ्लेक्शन क्या होता है कि व्हेन लाइट रे पासेस फ्रॉम ऑप्टिकली डेंसर टू रेयर मीडियम। ओके, टोटल इंटरनल रिफ्लेक्शन दिस फिनोमेना टेक्स प्लेस व्हेन लाइट रे पासेस फ्रॉम ऑप्टिकली डेंसर टू रेयर मीडियम एंड लेट्स सी व्हाट हैपेंस देन। तो जब लाइट डेंसर से रेयर मीडियम में जाएगा देन व्हाट विल हैपन। सपोज दिस रेयर मीडियम रेयर मीडियम and this is denser medium. Okay. Normal at this point. Say light rays passing from denser to rarer. This particular angle of incidence. The denser to rarer, then it will go away from normal. So it will go away from normal. Now suppose this angle of incidence increases in denser medium. This angle of refraction. If angle of incidence increases in denser medium, this I dash, then angle of refraction will also increase. Now suppose in that case the angle of refraction increases to this point, just at the interface of the medium. I increases, R will increase, and now say the value of I is such that the R is 90 degree. Refracted ray is at the interface of the two media. Okay? Then in this situation, this angle of incidence is known as the IC. IC means critical angle. That is known as critical angle. Alright? What happens? Light ray passes from denser to rarer medium. Denser मतलब optically denser to optically rarer medium. Then it goes away from the normal. That we have seen. It will go away from the normal. Now say this angle I, this reflection R. Now if I increases, then R will increase. Say at this particular value of I, R is 90 degree, means refracted ray is at the interface of two media. Then this angle of incidence is known as the critical angle. Okay? Refracted ray is at the interface of two media, means angle of refraction is 90 degree. Then the angle of incidence in denser medium is known as the critical angle. Alright? So critical angle. Now, if again say this angle of incidence increases, that is more than IC, then what will happen? If angle of incidence is this, then again the R will increase. It means the ray will be reflected back in the same medium. So this angle of incidence I1 and that is angle of refraction. It means that it is not, the ray is not refracting. It is reflected back in the same medium. So that is why this phenomenon is known as the total internal reflection. Total internal reflection इसका मतलब क्या होगा कि एंगल ऑफ इंसिडेंस इन डेंसर मीडियम is greater than the critical angle, then the ray will be reflected in the same medium. That is why this phenomena is known as total internal reflection. Alright? So, now we have two things. First, critical angle. I see. Critical angle is what? Angle of incidence in denser medium when angle of reflection in rarer medium is 90 degree. Alright? And total internal reflection will take place when angle of incidence in denser medium is more than the critical angle. Then no ray will pass in rarer medium. Okay? So for total internal reflection, what is the condition then? For total internal reflection, ray should pass, ray of light, ray should pass from denser to rarer medium and second, angle of incidence should be greater than critical angle. Should be greater than critical angle. Okay, that is I is greater than IC. So, and this is the condition for total internal reflection. Total internal reflection condition क्या हो गया? कि ray must pass from optically denser to rarer medium. And angle of incidence in denser medium should be greater than the critical angle. And what is the critical angle? Critical angle is the angle of incidence in denser medium when angle of refraction is 90 degree in rarer medium. Alright? So this is the case. Now, if you apply the Snell's law, then what will happen? So, as per Snell's law, this rarer medium say air and this denser medium say glass. So light ray is passing from glass to air. So by Snell's law, G mu A, glass to air, G mu A, at that particular angle of incidence, critical angle. So sin IC, sin I by sin R, and R in this case is 90 degree. When angle of incidence is equal to critical angle, I say, then angle of reflection is 90 degree. So by Snell's law, G mu A, ray is passing from glass to air. The G mu A is equal to sin IC upon sin 90 degree. So that is sin of IC, critical angle. It means A mu J, refractive index of glass with respect to air, that is because refractive index of medium is with respect to air or with respect to vacuum. Why? Because velocity of light in vacuum and air is almost same. So A mu G is equal to 1 upon sin of IC. In general, refractive index of any medium mu is equal to 1 upon sin of IC. Refractive index of any medium, that is with respect to air or vacuum, that is 1 upon sin of IC, 1 upon sin of critical angle. So this is the case of total internal reflection. Now let's see some application of this. Okay. So first application, पहला एप्लीकेशन क्या है? टोटली रिफ्लेक्टिंग ग्लास प्रिज्म. ओके, टोटली रिफ्लेक्टिंग ग्लास प्रिज्म. टोटली reflecting glass prism. Okay. Last year we have this right angle prism. This 45. It means this is also 45. Okay. Critical angle for glass is approximately 42 degree. Critical angle for glass is approximately 42 degree. Now suppose any object is here. This object AB is here. तो फिर इसका इमेज आपको कैसे दिखेगा? Around this side or around this side, how this image of the object is formed. Now see, the ray that starts from point B. So at this surface, it is normal, so it will pass straight. At this surface, the ray is not normal. तो हम क्या करेंगे? यहाँ पर नॉर्मल ड्रा करेंगे. ओके, इस फेस पर ये रे नॉर्मल नहीं है, तो यहाँ पर हमने नॉर्मल ड्रा किया. इसका मतलब क्या होगा कि इंसिडेंट रे एंड नॉर्मल, दिस इज द एंगल ऑफ इंसिडेंस I for this surface. And that I, if this angle is 45, then you say this is 90, this is 45, it means this is 90. So I in this case is 45 degree. It means this angle of incidence for this surface is greater than the critical angle, because critical angle from glass is approximately 42 degree. So the condition of total internal reflection is satisfied. क्लियर कि इस फेस के लिए हाइपोटेनस, इस फेस के लिए जो एंगल ऑफ इंसिडेंस है वो क्रिटिकल एंगल से अधिक है. एंड फॉर टोटल इंटरनल रिफ्लेक्शन वी हैव सीन दैट एंगल ऑफ इंसिडेंस मस्ट बी ग्रेटर देन द क्रिटिकल एंगल. सो दिस रे इज रिफ्लेक्टेड. नाउ इफ दिस रे इज रिफ्लेक्टेड, इट मीन्स द लॉ ऑफ रिफ्लेक्शन विल टेक प्लेस. एंगल ऑफ इंसिडेंस इक्वल टू एंगल ऑफ रिफ्लेक्शन. So at 45 degree the ray will be reflected, means from normal. So along this face at the base, it is along the normal, so it will pass straight. All right. This is clear? Okay. See, the ray that starts from B, at this face, it is normal, so it will go straight. At this particular face, it is not normal, so we will write normal here. So this is angle of incidence. The angle of incidence, if this 45, this is 45, then this is 45, because this normal is there 90 degree. So angle of incidence I is greater than the critical angle. So total internal reflection will take place. And when the ray is reflected back, at this base of the triangle, it is normal, so it will go straight. Okay? Now second ray that starts from point A, by the same reasoning, उसी तरह से आप देखो कि एट दिस पॉइंट अगेन इट इज रिफ्लेक्टेड. So point A will appear somewhere here and point B will appear somewhere here. तो इस तरह से जो इमेज हमें दिखेगा वो ऐसे दिखेगा. तो along the base the image will appear like this. All right. The ray that starts from point B at this face, take say MNP triangle. At the face MN, this ray is normal, so it will go straight without deviation. At face MP, this ray is not normal, so we will draw normal here. So angle of incidence I, that will be 45 degree, which is greater than the critical angle. So total internal reflection will takes place. It means the reflected ray, reflecting angle of reflection, that is also 45, because angle of incidence equal angle of reflection. The reflected ray will be normal to face NP, so it will go straight. Similarly, the ray that starts from point A, it will go like this. So image of this object will appear like this, A dash B dash anywhere. All right. In the same situation, suppose this angle is 90 degree. This 45. In the same tree, now say object is here. अगर ऑब्जेक्ट इधर है, along the side of hypotenuse, then where will be the image? How it will be observed? So by the same reasoning, आप देखो, the ray that starts from B, normal at this face MP, it will go straight. At this face MN, it is not normal, so we will draw normal here. So this angle of incidence, again it is 45. Because this 45, then this is 45. So again I is greater than IC, so it will be reflected. Total internal reflection will take place. Now this ray is again, it is not normal at this surface, MN. So again we will draw normal here. Alright. So now see again this 45, then this is 45. So total internal reflection will take place, so it is reflected like this. How this is so? Because this angle is 45, then this is 45. This 90 degree means this is 45. This totally 90, so again it is 45. Greater than IC, so it is reflected back like this. Clear? The ray that starts point B, it is normal at face MP, so it will go straight. At face MN, it is not normal, so normally drawn here. यहाँ पर normal draw करेंगे. Then incident ray and normal, that is angle of incidence. This 45, it means this is 45, so I will be 45 degree, which is greater than IC, because IC is for glass around 42. So total internal reflection which takes place. Now in this reflected ray is incident on face Pn. Again it is not normal, so we will draw normal here. So angle of incidence is again 45. So total internal reflection will take place here also. Clear? Similarly, the ray that starts from point A by the same reasoning, it will be reflected from that point. So image will appear like this. This point A, this point B. So inverted image is formed. Alright? Okay. So this is one of the application of this total internal reflection. And let's say another application, another problem, or you can say numerical based on this, like question based on this total internal reflection. So question is that we have this, say, water, okay. I say a point source of light is placed here at the bottom. A point source of light is here. This point source of light, say a small bulb, and the light is coming out through this particular region only. इतने एरिया से लाइट रे बाहर निकल रहा है. ऑब्जेक्ट इज हियर. तो इतने एरिया से अगर लाइट बाहर निकल रहा है तो व्हाट विल बी दिस एरिया. ओके, इसका मतलब क्या हो गया कि the ray of light at this point, it is not going out in the rarer medium, so it is like this. Similarly, the ray which is incidence along this side, so again it is, if you draw normal here, it means this is the angle of incidence and that is critical angle because refracted ray is 90 degree. क्या ऐसा हो रहा है? तो कहा कि इतने एरिया से ही लाइट बाहर निकल रही है. इसका मतलब नो लाइट इज कमिंग अलोंग दिस डायरेक्शन. सिमिलरली नो लाइट इज कमिंग अलोंग दिस डायरेक्शन. Okay, so this will be the critical angle. Angle of incidence will be critical angle. तो अगर ये critical angle है and this depth से h, ये depth कितनी है? h है. तो हमें ये एरिया निकालना, कितने एरिया से लाइट बाहर निकल रही है. तो आप देखो, ये क्रिटिकल एंगल हुआ. इसका मतलब ये क्रिटिकल एंगल हो गया. इससे अल्टरनेट एंगल, दिस रेडियस से आर. क्वेश्चन समझ में आया? वाटर, एयर, a point source of light is based here at a depth h. अब आपसे कहा गया कि इतने एरिया से लाइट बाहर निकल रही है. इसका मतलब क्या हो गया? this is the last point. No light is coming along this side and similarly no light is coming along this side, क्योंकि इतनी ही एरिया से लाइट बाहर निकल रही है. इसका मतलब क्या हुआ कि जो ray of light which is originating from this point is refracted at the interface, क्योंकि इधर से कोई लाइट बाहर नहीं निकल आ रहा है. इसका तो यह एंगल क्या हो गया, क्रिटिकल एंगल हो गया. इसी तरह से यह एंगल क्या हो गया, क्रिटिकल एंगल हो गया, बिकॉज नो लाइट इज कमिंग अराउंड दिस डायरेक्शन. ओके, तो हमें ये एरिया निकालना है. तो आप देखो फ्रॉम दिस, तो R बाई एच दैट इज साइन ऑफ आई सी. एरिया कितना हो गया, कितने एरिया से लाइट बाहर निकल रही है, तो एरिया विल बी इक्वल टू पाई आर स्क्वायर. इतनी एरिया से लाइट बाहर आ रहा है. क्लियर? थ्रू दिस एरिया द रेज आर कमिंग आउट. नाउ फ्रॉम दिस ट्रायंगल सी R by H is equal to tan of IC perpendicular upon base. Tan IC मतलब sin IC upon cos IC. And that is equal to sine of IC upon cos IC means under root 1 minus sine square IC. Sine IC is 1 by mu, that we have seen in total inner reflection, upon root of 1 minus 1 by mu square, because mu is equal to 1 upon sine of IC, that we have seen. Okay. R by H, that is tan IC. Tan IC is sin IC upon cos IC. Cos IC 1 minus sine square IC, so we have this result. All right. It means अब यहां से आपको क्या मिलेगा, so R by H that will be equal to 1 by mu upon under root mu square minus 1 by mu square, that is mu. So ultimately you will get 1 by mu upon under root mu square minus 1 by mu. So that is 1 by root of mu square minus 1. That mu is cancelled. So we have this result, R by H is equal to 1 upon root of mu square minus 1. Mu, that is refractive index of this medium, water in this case. Alright. So you will get R is equal to then we have I is equal to H upon root of mu square minus 1. It means area is equal to pi r square. So that will be pi I square is this H square upon under root, mu square minus 1 square, it means that is mu square minus 1. So through this area the light is coming out. Clear? क्वेश्चन क्या दिया गया है, पॉइंट सोर्स ऑफ लाइट इज प्लेस्ड एट द बॉटम एट ए डेप्थ h। अब इस सोर्स से इतनी एरिया से लाइट बाहर आ रही है, इसका मतलब क्या हो गया कि जो रे यहां से ओरिजिनेट हो रहा है वो इट इज रिफ्लेक्टिंग एट द इंटरफेस बिकॉज नो लाइट इज कमिंग अराउंड दिस डायरेक्शन, सो दैट इज 90 डिग्री। सिमिलरली जो रे इधर इस साइड में इंसिडेंस है, अगेन द एंगल ऑफ रिफ्लेक्शन is 90 degree. Alright. It means this is the critical angle because refracted ray is at the interface, so angle of reflection is 90 degree. तो अगर ये IC है तो IC हो गया alternate angle. R by H will be tangent of IC and then we get this result. 1 upon this. Area will be pi h square upon mu square minus 1, mu the refractive index of that medium where the source of light is placed. Okay? Alright. So, some more application of this total internal reflection we will discuss in the next class. So that's all for today. Thank you.